Alright, today we're going to look at further work with the complex roots of unity. So, we can investigate the solutions to the nth roots of 1. We're going to work with a symbolic representation of the roots rather than actual value. It's important to remember, as you've hopefully seen in the holiday homework I've set for you, that we can factorise w to the n minus 1 as such. So we can prove this general factorisation by expanding the right-hand side or by regarding 1 plus w squared as the sum of geometric series, which you're going to look in advanced maths later on. So when you are given names for each individual root of unity, for example, w1, w2 and w3, being the cube roots of unity, you actually find the roots. But if you're told w is one of the roots, then you don't need to find the actual values of the roots. We're dealing with them on a general basis since we don't know which root w is. We're just going to do one example in this video because they take a very, very long time to do. We're going to have a look at... What do we want to look at? We might look at example... this one down here. If w is a non-real cube root of unity, show that w bar is also a root. Well, the cube roots of unity are defined by... the cube roots of unity defined by z cubed equals 1. And if w is a root, then that means w cubed is 1. And if we take the conjugate of both sides, we get this. But by our conjugate theorems in one of our last lessons, we learnt that this is the same as that, and 1 bar is just 1. And since we have just subbed w bar into z cubed equals 1 here, we go therefore w bar is a root. Now, the cube roots of unity, 1 will always be a root of unity because the nth root of 1 is always 1. So if we have a look, we've got z cubed, and then if we actually write this plus 0z squared plus 0z minus 1 equals 0, we go minus plus minus, the sum of the roots of this equation is actually 0 or negative 0. So we've got that 1 plus w bar is equal to 0 by the sum of the roots. In part C, 1 plus w squared. Well, we're solving the equation z cubed equals 1, which is by solving z cubed minus 1 equals 0, which means we've got z minus 1, which is z squared plus w plus 1 equals 0, plus z squared plus z plus 1, But w is a root, so that means by the null factor law this is true, and since w is a root, therefore w squared plus w plus 1 is equal to 0. And our last one, this is really what I wanted to get into this video, which is why I chose this one. 1 plus w squared cubed times by 2 plus 3w plus 3w squared is equal to 1. Now we proved in an earlier part that 1 plus w squared is equal to 0, which actually means 1 plus w squared is equal to minus w. So we can replace this with minus w cubed outside of 2 plus 3w plus 3w squared. We can't say it's equal to 1 at the moment because that's what I'm trying to prove. I might need to add another page here. Oh, not that one. And we want to try and get rid of everything, so we've just got 1, because I actually know w cubed is 1 because it's the root of unity. So minus w cubed would be minus 1. So in an ideal world, I'd like this to be minus 1. And we're going to try and write this in expressions that use 1 plus w squared. So this is the same as 2 outside of 1 plus w squared plus, well, we need one more w and one more w squared. Now we've discussed that w plus w squared is minus w. Oh no, we said w plus w squared was minus w, and we also can deduce, we said 1 plus w squared, is minus w, which means w plus w squared is minus 1. So we can go, okay, well, we've got negative w cubed, 2 outside of that's 0, and then this is minus 1. With negative w cubed times 0 minus 1, which is minus 1, and w cubed is equal to 1, so therefore we've got minus 1 times minus 1, which is 1, which we wanted, QED. Okay, thanks for watching.